Hey everyone, welcome to the final tutorial. Today we'll be talking about debugging in Python. So open up VS Code and connect back to that node that you used in tutorial 3. So I'm going to connect current window to host, and since I used Z3 last time, that's what I'm going to connect to again. So open that up. And we're going to be using that same repository that we used last time, which is simple neural net. So you can see right now we don't have a workplace open. And so let's open it. So remember, we say code, and then if we do -R, it reuses the current window, and then we'll do simple neural net. So let's do that. And I'll kind of refresh the window. And notice this is super cool. Since we opened it as a workplace, it remembers what files we had open previously, which I think is kind of neat. And also we can now see all of our files in the Explorer, and it's integrated with Git, and there's a lot of other features and benefits from opening a directory as a workplace. Okay, so now that we're in here, let's get debugging. So there's two main ways that we can kind of run the debugger. We can either launch or attach. And so I'm going to show you the attaching first. I think this is a little easier and maybe more applicable as well. So what we're going to do is we are first going to make sure that we have all the dependencies that we need. So we actually need to install a library called Debug Py. And so maybe we can just say conda list grep debug py. Let's see if we have that. And it doesn't look like we do. So let's say, oh, well, part of it is that we're not in the correct environment right now. So let's say first conda activate, then I'm going to say net. Perfect. And then let's run that command. Okay, so we do have debug py, but if for some reason you don't, just say conda install, and then for your channel, say conda forge and debug py. And by doing that, you will install that package, which we need. And it should just tell us that we already have it. Perfect. Yeah. Okay, so that package is already installed. Okay, so remember, this is one of two ways to run the debugger. So way one is to attach. And what this means is that you're going to run your Python file normally, how you normally would. And then you have some statements in the code that basically wait for the VS Code debugger to attach. So first thing we need to do is say import debug py. And then it's really just like 3 lines of code. So then we're going to say debug py dot listen, and we're going to give it a port to listen on. And the default port is 5678. So that's what I'm going to do. And then we're going to say debug py dot wait for client. Sweet. So this makes it so that we're listening for VS Code to attach. And this makes us kind of pause execution and wait at that point until we've actually attached. If you don't have that line, it'll just continue to execute the code as normal. And I mean, you can attach at any point, but it won't wait for the debugger at all. So, okay, now that we have that, let's run train.py. So we're going to say Python train.py. And you can see that nothing's happening right now. It's just hanging. And that's a good sign. That means that it is waiting for the client. And I think sometimes that can be maybe a little bit confusing. So what I like to do is I'll like print something like waiting for debugger. And then I'll say like attached. And let's add those lines. And so now when we run it, we should see waiting for debugger. Perfect. Okay, so now that we've run our code, but it's paused execution, it's waiting for the debugger to attach. We can click on this button right here, run and debug. And we're going to create a launch.json file. So click on this. And what we want to do is the remote attach. Remember, that's kind of the method that we're using right now is attach. So let's click on that. And for the host, just say localhost. We're using the current machine that we're on. And then 5678 for the port, because that's the one we're listening on. And once we do that, it should open up this launch.json file. And there's kind of, so this is just like a JSON configuration file. So it's just a bunch of like key and value pairs. And the name we can change to just, I usually just change it to be attach. This is just like an alias for the configuration. Type Python request attach, connect, localhost, and port. So we keep all that the same. Honestly, I don't think you really need this part, so I usually just delete it. And there's our configuration. So now you'll notice that you have a valid configuration here called attach. And so I'm going to save this file right here. And I'm going to press this play button to attach. So here I go. And you can see that we got attached. So what's really interesting is that it's printing things out both in the terminal and this debug console, which we haven't used before. So I think the things in blue are what got like printed on std out. And so, yeah, you can see our neural network is working as usual. But our debugger is attached, which is really cool. Now, it doesn't really mean a lot until we actually set a breakpoint. So let's see if we can do that right now before it finishes executing. So to set a breakpoint, you just kind of come over to this gutter right here and then just click. And you'll see that it will just pause at that breakpoint. And there's a number of different variables that you can look at. Also, this like little menu bar popped up. So let's look at this. This is to resume execution. This is to like step to the next line of code. This is to step into. This is to step out of. Generally, you shouldn't click on the restart if you attached like we did. So I would ignore that one for now. And then there's also disconnect. And that'll just kind of disconnect the debugger and just let it execute normally. So that's actually what I'm going to do right now. I'm going to disconnect. And so it'll just kind of finish doing its thing and executing. You probably won't see output on the debug console anymore. You'll probably have to go to the terminal to see it finish. Okay, so it's done. That's great. But now what we're going to do, let's set a breakpoint pretty early on here. We're going to set like a breakpoint right here. So this is the first line of really the start of our program. And same thing, we still have this kind of block of code to attach to the debugger. So let's clear this out. And then we're going to say Python train.py. Okay, and it's waiting for the debugger. So now we can click on run debug. We can click on attach, which is our configuration that we set up previously. Okay, and it paused on our breakpoint. So now let's kind of do some of these other options. So to just go line by line, we can do step over. And that's kind of nice. You can see it's just kind of progressing line by line here. And what's really nice is that you have access to all of your variables. So all of your local and global variables. And so, for example, like args, those are all like our command line arguments. And let's take a look at that. So we can click on this right here. And you can see our batch size is 64. The device is none. Epochs is 5, learning rate is 0.3. Those are all the default arguments because we didn't specify any command line arguments. But this is really nice. You can kind of just like go through and it's kind of set up like a tree. So you can just kind of progress through each branch and keep going down and look at these nested variables. So instead of going through line by line, now what I'm going to do, I'm going to set another breakpoint like down here. And so then I'm just going to click on this resume button, and this will continue code execution until I hit another breakpoint. So it should stop me right here. So let's see what happens. Yep, you can see it paused me right here, which is nice. And this is essentially our training loop, right? So we're just going to keep doing train and test. Okay, so let me get rid of these breakpoints. I'm just going to click on them again to get rid of them. And now what I'm going to do is I'm going to set a breakpoint up here in my training function right here. Okay, this is where we're about to push X, which is like all of our images through our network. So now I'm going to resume training again, and it should pause us right there. Perfect. And now what I'm going to do is I'm going to click step into. And all this does is that if we happen to be at a function, it will go into that function instead of like passing over it. So for example, if I do like step over, we don't actually go into that net function or object rather. Here, I'm going to click on resume to get back to that breakpoint. But now let's actually step into. So we're going to step into that. And here we are, we're passing X, which is all of our image data through our network. And we can either go line by line like this. And maybe if we get tired and we're kind of done with this right now, we can do step out of, and that will just take us to the next level, kind of where we stepped into things. So I'm going to click on step out, and you'll see it takes me right back to where we stepped in. Nice. Okay, so then I'm going to resume again to kind of go back around, and let's step into again. All right. So I'm not sure how familiar you are with tensors. You might have a lot of experience with PyTorch and tensors, and you might not. But tensors are basically how you store data in PyTorch. And so it's storing all of our image data. And since we have a batch size of 64, we basically have like 64 of these like matrices of information. And so let's look at that. So we have locals right here, our local variables X. And it's really hard to like see what's going on. There's actually a lot of information there. Oh, look, it's giving us a little preview, but it's really tough to see right there what's really happening. So what we can do is we can right click on this and we can click on view value in DataViewer. And if we do this, oh, it says Python package pandas is required for viewing data. Okay, let's install that. So we'll give it a second to install this. Okay. Now check this out. This is amazing. So it's loading the data viewer. And what it's done is it should show us like all of that information right here in this grid. So here's like all that image information. It's just like a giant matrix, really for just like the first image you can see. And you can slice the data in a bunch of different ways. You can even filter values. So you can say, oh, I only want it when it's like, when this is greater than 0. And so you can see that column, all the values here are greater than 0. So you have some like really powerful like tools to inspect your data as it's passing through a model. Really, really amazing. You can select the axis or the index that you want to look at. So I won't go too much more into depth on this. You can kind of explore this on your own. But some really cool stuff to kind of inspect data. Another thing that we can do, so let's look at X, and I want to look at the size of X as it kind of goes through the model. It'll actually change. So let's see if we can find that. Or shape. We're going to look at the shape, not the size. That works. So yeah, so this is the shape. So 64, because we have 64 images in our batch. 1, because they're black and white images. If they were color, we'd have 3 for RGB, red, green, and blue. And then they're 28 by 28 pixel images. So there we go. And now watch as we kind of step through, you'll notice that that changes. So the shape is now 64 by 784. Now 512, still 512. And then it should end with 10. There it is. Yeah, 10, because we have 10 different classes. Cool. Well, but you notice that like as we were kind of progressing, all the variables changed, and it was kind of disorienting and hard to figure out where our variable went that we really care about. So what we can do is we can right click on this and we can say add to watch. And we have this separate little like watch category right here that just is in a convenient location where it won't get lost. And so here, let's kind of like, let's continue again. So it's going to get back here, and then we're going to step into our network again. And you'll notice that now as we step through, we can just look at this watch and kind of pay attention to it as we go through, which is really nice and convenient. We can remove things from the watch if we'd like. So let's say remove expression. We can also add things to the watch right here. So we can say plus, and let's just say x.size. And so there we go. It's back on the watch. We can add anything to the watch. We can add the entire tensor itself. But this is just really good for kind of keeping track of data and variables as you're kind of debugging. You'll also notice this breakpoints tab. So if I start like here, I'm going to start posting a bunch of breakpoints. Each breakpoint that you put down shows up here, and then you can just really easily toggle them on and off. So maybe you don't want to get rid of it entirely, but you just want to toggle it off. Or maybe you want to toggle all of them off. You can just click on this right here, turn them all off or all on. So that can be really convenient than having to go through your code and click all of them one by one. It shows you the line number that each breakpoint is on as well over here. Sweet. So that is all very cool. Also the call stack, that kind of just keeps track of like, as you're going into functions, that progression of like how deep you go into the functions. So we started like at the top level, and then we went into the training function and into the forward function of our neural network. So sometimes that's nice information as well. Okay, so what I'm going to do is I'm actually going to remove all breakpoints by clicking on that button. And I'm also going to remove all things that we're watching. And now I'm going to show you something cool. So we've been setting regular breakpoints like this, but there's some advanced options for the breakpoints. So the first one I'm going to show you is a conditional breakpoint. So let's come down to our test function. And so let's come right here, correct. So correct gives you basically like the percentage of images that you guessed correctly. So what I'm going to do is I'm going to set a breakpoint right here, but I'm going to right click instead of left clicking. And then I'm going to say add conditional breakpoint. And so I can choose when this breakpoint breaks. It won't always break, only when this expression that I write right here evaluates to true. So I'm going to say, okay, only when, so correct is going to be like a value between 0 and 1. 0 if it got none of them correct, and 1 if it got 100% of them correct. So I'm going to say, okay, well, I only really want to break if my model is doing pretty poorly. So I'm going to say only break when correct is less than 0.8. Maybe that's what I define as pretty bad. And so I'll just press enter now. And now let's resume execution by clicking on this button. And you'll notice that it's never hitting that breakpoint. And that must mean that our accuracy is pretty good. Oh, I actually finally hit it. I think what it was doing was it was going through the training function and hadn't yet gotten to the test. Okay, so we broke on this. So that must mean that our percent correct is less than 0.8. And we can kind of verify this by going to the debug console. So the debug console is amazing because you can evaluate any expression right there on the spot and it will give it to you. So let me show you what I mean. If I just say like correct, there it is. So our percent correct was 0.64, which sure enough is less than 0.8, which is really cool. And now let's kind of like just continue through this. Maybe we'll add correct to the watch. We'll say correct. Not available at this time, but it will be. Ooh, 0.65, not much better. So I think it will continue to break. Yeah, you can see that it keeps breaking. But however, maybe let's change this conditional breakpoint. So we'll say edit. I'll say if it's less than 0.6. And now when we run it, it should never hit that breakpoint. So yeah, kind of cool. You can set different conditions there. And here, I'm just going to disable it for now instead of just deleting it. So yeah, that's pretty cool. Now that it's finished, we're going to have to kind of restart our debugging process here. So we'll say I have two different terminals. Let me close that one. Okay. We're going to say Python train.py. Okay. And we need to attach the debugger because it's waiting for it right now. Okay, so there we go. It's attached. So what I'm going to do this time is I'm going to put a breakpoint like right after we get our predictions. So right here. Okay. And let's talk a little bit more about the debug console. I kind of like briefly showed you that, but this is really cool. So you can literally put any value there and it will just instantly evaluate it. So I can say like pred.size and it'll give me the size. I can say like pred, give me the first prediction or give me the second prediction. And it just instantly evaluates it so that you can see it. But I can do that with any of the variables that are in scope. I can just like evaluate them. And yeah, expressions too, right? So like I can do math expressions and it evaluates them. And what I'm going to show you now is, I think, even more impressive. You can even like call functions. So let's make sure that we have this function. Let's see here. So I created a function in utils.py and it's called getResult. Let's make sure that that exists. I'm going to say getResult. Okay, so it doesn't. So I'm going to say from utils import getResult. And now let's see if it shows up. It does. Okay, so we have this function getResult that is from this file utils.py. And I'm actually going to call this function in the debug console. Check this out. So what this function basically does is you give it a prediction and you give it the actual value. And then it prints out kind of in like human readable terms what the predicted item of clothing was and what the actual item of clothing was. So this is like really useful for debugging. It's a really nice function here. It's actually the function that we use in test.py as well. But let's call it here. So I'm going to say, first of all, I'm going to say get result. Oh, and I forgot to mention one thing. So it will often like give you these like helpful suggestions, and I always press enter, and that's not the right thing to do. You actually want to press tab to kind of like auto-complete that option. Okay, and then we're going to give it our prediction. So I can say like pred 0. That's the first prediction, and then I can say y 0, and 0 y is like the truth. It's like the actual label. So if I do this, let's see what we get here. So predicted was ankle boot, actual is ankle boot, and let's change it here. We can say like 1 1. Nice. And yeah, we could do that for like any sort of values, right? Let's look at 3 and 3. And that one, it got correct too. So really cool. Like you can literally call functions in this little debug console and run different expressions. And I think it's really helpful because it's during runtime. You don't have to like stop execution, put in print statements or put in some like debugging statements and go back. You can literally just have it right there in this debug console. Super, super cool. Okay, so now that we've kind of looked at that, there's one last thing that I want to show you with kind of like the debugging tools, and that is a different type of breakpoint called a log point. So often, I mean, I think if you are a programmer, you've probably done a lot of print debugging in your time, right? So if you can't figure out what's going on, you print out values of different variables. And then you have to go back after you're done debugging and delete all those print statements. And it's kind of obnoxious. And what if there are a way that you could like toggle those print statements only when you were debugging and then toggle them off when you actually wanted to execute? That's kind of like the idea behind log points. They log different things to this debug console so that you can see them when you're debugging. But when you actually run the code, there won't be any print statements there that you have to get rid of. So let's go back to our debug tools here. I'm going to toggle this breakpoint off. And what we're going to do, you can see this like statement right here. We're going to turn it into a log point. So yeah, let's talk about what's going on here. So basically, like every time you've hit 100 batches, what we do is we print out the loss and like how far along you are in your training. So current tells you like essentially what epoch you're on out of the total number. Sorry, not epoch. What iteration you're on out of the total number of iterations. So we're going to take all of this and just turn it into a log point so that it never actually prints stuff out. So what I'm going to do, I'm going to highlight all of this. And if I say control/, I can toggle comments. So I can turn it off or on, just that control slash. Super cool. If you're using a Mac, it's probably going to be command slash. So I'm going to just toggle this off by selecting everything and then doing command slash. And then let's set this log point. So I'm going to come over here. I'm going to say add a log point. And so here's our log to message when breakpoint is hit. Expressions within this are, the brackets are interpolated. So this is pretty sweet. So we can say something like this. We're going to say loss, and then we're going to say loss.item. And then we're going to say brackets, and then we'll say batch times length of X. Okay. And I want you to see that this is like literally what I have down here, right? The only difference, like if you're familiar with F strings, it's essentially what's going on here. So whatever like variables you put in these like little curly braces will be evaluated. So it won't literally print out loss.item, but it will evaluate that and then print out the evaluation. So we're basically saying, here's my loss, evaluate this in the curly braces. And then here's like the current iteration I'm on, which I find by doing batch times the length of X. And then here is the total size. So the total number of like images that I have to go through. Okay, so if we do this, let's press enter. And now let's just start running things. And we're going to look at the debug console. Sweet. And you should see that it's like, it's just printing it out a ton. Yeah, so as you can see, there's a lot that you can explore with these different breakpoints. So we talked about regular breakpoints, conditional breakpoints, and log points. And each one of these like have kind of these different options. So even if you set like a regular breakpoint, you can choose to log a message when it breaks. And you can add an expression and you can add a hit count. So for every type of breakpoint, you can do these things, which is really cool. So I won't like go too much more into depth on this, but definitely explore it and know that it's there so that you can try it in the future. Yeah, I'm just going to continue execution now. Sweet. So we've talked about a lot of cool things. We've talked about the variables that we can see, about like adding a watch on certain variables. We talked about how you can toggle breakpoints on and off. We talked about the call stack. We talked about the debug console and how it can literally call functions and just evaluate any type of expression, which is really cool. And it all started with attaching the debugger. So remember in the beginning, I said there's basically two different ways to run the VS Code debugger, either attaching after you've run the process, or you can launch the debugger with the code. So at this point, I'm going to just show you that to wrap up, and it will be pretty fast. So what I'm going to do, I'm first going to just end execution here by doing Control-C, and we'll kind of finish that up. And now what I'm going to do, I'm going to select all of this and do Control/ to comment that out. And I should mention what I often do in practice, instead of having to like write all of these lines of code and then like copy them into certain files that I want to debug, I'll often just create a function called like attach debugger that then I can call. So I could say something like, oh, utils.attach debugger. And that has all of these lines of code just in this single line. And I can put that in whatever files in my workplace that I want. So I find that pretty useful. Okay, so that was the attaching method. Now let's go into the launching method. And what we're going to do is we're going to come here and we're going to say add configuration. And we want to do a Python configuration. So let's click on that right there. And we want to do a Python file. All right. Let's name this configuration something. So all of your configurations are in the same file. So here's like our attaching configuration that we had before. And now this is the new configuration that we just created. And here's the default name. It's just an alias. You can call it whatever you want. So this one happens to be called Python current file, because whenever you run this configuration, you can see it has this variable that it's evaluating, and it will just always run the current file that you're looking at. But instead of doing that, let's kind of switch this up. So we're going to say, maybe we'll just call this train.py. And so then that means that for program, we're going to put the name of the file that we want to run. So I'm going to say train.py. And you could put an absolute path. That's probably a little bit safer. But as long as you kind of like run this configuration in this main directory, I think you'll be okay. So let's talk about this. So type is Python. That's the same as before. Notice that the request is different. So this is launch, whereas before we were attaching to an already running process. So this actually launches our code. And this is very similar if you've ever like used like PyCharm to kind of set up different configurations. This is kind of the same idea. So you're actually launching the code with the debugger. And so what you probably want to do is oftentimes there are like command line arguments that you want to add in. And I've kind of glossed over this, but in this program, we have a bunch of different arguments. So we have number of epochs, we have batch size, we have learning rate, and we have device. And we've just kind of been using the default values for all of these because we haven't specified them when we've been running our program. But there are times when we would want to specify these to something different, and we can do that in this configuration. So the way this essentially works, everything has to go in this list right here. And you just have key value pairs, and they're just strings that are just together. So essentially, this is what it's going to look like. And they could all like be on the same line, but I think this looks a little bit ugly. So what I usually do is I have like one set of key value pairs on each line. And you'll probably see what I'm talking about in a second here. So let's go back to train.py. Let's look at our arguments and say we want to set the epochs argument, command line argument. So I'm going to copy that. And I'm going to go to my launch.json. And for number of epochs, let's say I want to run for 10 epochs. And then let's do the next one, our batch size. So maybe I want a little bit of a bigger batch size. So I'm going to say 128. Notice that even numbers are still in quotation marks. So they're still going to be strings. Everything has to be a string. Okay. And then we'll do the learning rate last. So we can copy this in. And for the learning rate, we'll just say like 0.1. Perfect. And again, like all of these could be like formatted on the same line. Like potentially you could do this. But I just think that looks really messy and it's kind of hard to read. So I usually kind of have individual key value pairs on separate lines. Great. So now that we have all of this set up, we can go to our configurations and we can click on this new one, train.py. And let's run it by clicking on this play button. And it starts the debugger just as before. But I guess the difference is that it's actually launching the process. Before we had like ran the process and we were attaching to it after the fact. This is actually launching the program for the first time. And it works just the same as before. So you'll see that all those log points that we set, they're still showing up in the debug console. If we set a breakpoint here, it will catch it. So same thing as before, but you just kind of spelled out all the command line arguments and your debugger is actually like launching the program and attaching itself as you launch. So just a little bit of a different paradigm, I guess. Those are the two main ways, are launch and attach. And I find myself using attach a lot more often because it's more flexible. I don't have to go in and I don't have to change all of these arguments for like every single run that I have to do. I can just type whatever I want into the terminal. So if I say like Python train.py, and then I can specify the arguments that I want literally on the command line instead of having to spell them out like this, which takes a little bit of time to kind of write everything out. So if possible, I would recommend just attaching. I found that it's a little bit more of a flexible model, a little bit easier to use. But if you absolutely have to create a configuration and you feel like you're going to use the same command line arguments over and over again, there's always this method as well. So that is just about everything that I wanted to show you guys. I know that was a lot of information all at once, but hopefully you can make some sense of it. And I'm going to post a link in the description where you can read a lot more about debugging in Python in VS Code. This was kind of just scratching the surface and giving you guys a high level overview of a lot of different topics. But it would probably help to actually dive in deep yourself and kind of read some of the documentation. So make sure to look at that in the description. And thanks for sticking around, guys. Best of luck with your internship. And thanks again for watching.